Hi students, today we are going to discuss about the important formulas in class 10. First formula is there, mirror formula. Mirror formula. Mirror formula 1 by f is equal to 1 by v plus 1 by u. Here f means focal length, v means image distance, u means object distance. Here everything we are measuring from the pole, students. Next formula is the linear magnification. Linear magnification. M is equal to Hi by Ho is equal to minus V by U. Here Hi means size of the image. Ho means size of the object. Height also we can call, no problem. Next is the student, very important question. What is the relationship between R and F? Relationship between R and F. R means radius of curvature, F means focal length. What is the relationship between these two means R is equal to 2F. Implies F is equal to R by 2 we can write. It means focal length is half of the radius of curvature. For example, is given radius of curvature is 40 centimeter, asking us to find focal length, then focal length is R by 2, 40 by 2, we will get 20 centimeters. This is the three formulas about mirror. First one is the mirror formula, second one is linear magnification, and third one is the relationship between R and F. Next, about lens formula. Lens formula also same like only having, but only small difference is there in the sign. We can observe that first one is there 1 by f is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. Here mirror formula with u have plus, here minus. This is only difference. Here also linear magnification M is equal to Hi by Ho is equal to plus V by U. Here is minus V by U, here plus V by U. That is only the difference is there. Next, we go to the electricity. Electricity chapter we can go. In this electricity chapter, so many formulas will come. In this first formula is there, charge Q is equal to plus or minus Na. Here N means number of electrons, E means charge of electron or charge of proton. Charge is equal to plus or minus Na. N means here number of electrons or protons. This is one of the important formula. Next is the electric potential formula. Electric potential V is equal to work by charge. V is equal to W by Q. From this we can write W is equal to VQ, work is equal to potential into charge, or we can write Q is equal to W by V, W by V. In the numericals, they will give W and Q asking us to find the potential means we can apply this formula V is equal W by Q. Next, electric current. Next is the electric current. Electric current. Before we are going to electric current, here one thing remember, sometimes they will call 1 volt is 1 joule by 1 coulomb. What is 1 volt is equal to 1 joule by 1 coulomb. This formula also remember, because SI units of electric potential is volt. Defined 1 volt means we can write 1 joule by 1 coulomb. This is also so many times asking in examination, so we should remember it. Next is the electric current. Electric current symbol is small I or capital I. I is equal to electric current, I is equal to Q by T. Q by T. This is the basic fundamental formula. I is equal Q by T. Q is here charge, T is the time. We can write this one. Q is equal to IT also. IT also. And also we can write T is equal to Q by I also. Q by I also. Any formula we can write. And also we remember SI units of electric current is what? SI units of I means electric current is ampere. Sometimes they will ask define 1 ampere. 1 ampere is equal to 1 coulomb by 1 second. This is also we should remember. 1 ampere is equal to 1 coulomb by 1 second. Next is the very very important students, Ohm's law. Ohm's law. Ohm's law. First remember, Ohm's law will give for us the relationship between potential difference and electric current. The difference between potential difference or voltage and electric current at a constant temperature. Here temperature should be constant. At a constant temperature. At a constant temperature. It means potential or voltage is directly proportional to current. Directly proportional to current at constant temperature. To equate this proportionality, we can introduce a R into I. It means main formula is that V is equal to Ri. Some members will write V is equal to IR also. R means here resistance of the conductor. Resistance of the conductor. Resistance of the conductor. This is one of the formula. Next we can go. What is the SI units of resistance? Sometimes asking what is the SI units of resistance? Resistance SI units is there ohms. Resistance SI units is ohm. Ohm. We can write as ohm also. This resistance is depends on some factors. Resistance depends on 4 factors, mainly 4 factors. What is the 4 factors? First one is the nature of the conductor. What is first one? Nature of the conductor. Nature of the conductor. Next, nature of the conductor means we can remember what material we are using. Material of the conductor also we can remember here. Second one is the length of the conductor. Second one is the length of the conductor. Length of the conductor. What is the relationship between resistance and length means R is directly proportional to L. Very very important relation. If length is increase, resistance also will increase. For example, they will give 1 meter and 2 meter wides. Which one having more resistance means 2 meters wide having more resistance, because when length is increasing, resistance also will increase. Resistance means to oppose the flow of current, to oppose the property to oppose the flow of current. This is one of the very very important relation. Sometimes they will ask if length is halved, resistance what happen means resistance also halved. If length is doubled, resistance also doubled. This is one point we should remember. Next is there area of the cross section of the conductor. Area of the cross section. Area of the cross section of the conductor. Area of the cross section of the conductor. How like the relation is there means R is direct inversely proportional to 1 by A. And 1 by A. Area is increasing, resistance will be decreased. Area is decreasing, resistance will be increased. If area is doubled, resistance is going to be halved. Resistance is going to be halved. If area is doubled, resistance is going to be halved. If area is halved, resistance is doubled. Last one is the temperature. Temperature. This is in the temperature, very interesting thing is temperature is directly proportional. Resistance is directly proportional to temperature only for good conductors. If we take good conductors, if temperature is increased, good conductors means we can take as silver, aluminum, copper, anything we can take as a good conductor. If temperature is increasing, resistance also will increase. Resistance also will increase. But when you take insulators, it is no change. Insulators we can change. Insulators we can take no change in the resistance if temperature increase also. So this one point we should remember. This is only for good conductors. Good conductors. This is the four factors mainly the resistance depends on. Next is there the formula resistivity. Very very important. Resistivity. Resistivity symbol is rho. Resistivity symbol is rho. Resistivity symbol is rho. We know here already we did what is first one is R is directly proportional to L. This is first. Next, R is inversely proportional to 1 by A. Second, from 1 and 2, from 1 and 2, we can write R is proportional to L by A. R is proportional to L by A. To equating this proportionality, we are introducing one constant. That constant name only resistivity rho L by A. Rho L by A. This is the main formula. And one more thing, remember this resistivity is resistivity we can call also specific resistance. What is specific resistance? We can call also specific resistance. Specific resistance. Here rho means what? Resistivity. Resistivity. Okay, from this formula we can say what we got. R is equal to rho L by A. From this, rho is equal to RA by L. RA by L. What is the SI units of resistivity? What is the SI units of resistivity? What is the SI units of resistivity or specific resistance means? We can observe here resistance units we know ohm, meter SI units is area SI units is meter square, length SI units is meter. Meter cancel out means ohm meter is the SI units of resistivity. Is the SI units of resistivity. This is the main things. Now we can go combination of resistors. What is next? Combination. Combination of resistors. Here two combinations we have. One is series combination, another is parallel combination. First one series combination, we can take a series combination. Series combination means we can connect in series like this. R1, R2, R3. Then formula we will get R is equal to R1 plus R2 plus R3. R1 plus R2 plus R3 we will get. That is only parallel combination we can take. Parallel combination. At the time the formula is, if you take three resistors, 1, 2 and 3. R1, R2, R3. Then we will get formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is parallel combination formula. Next we will go for electric power. Electric power P is equal to work by time. Here we can write power is equal to work by time. Work is in the form of energy. We can take E by T also we can write. E by T. E means here energy. E is equal to P into T. Electric power is equal to energy is equal to electric power into time also we can write. Next, here four formulas is there mainly. First we see power is equal to VI. How to derive this one? Power is equal to VI. We know potential is equal to work by charge. From this, work is equal to we write potential into charge, potential difference into charge. Now we can take here power is equal to work by time. This we are going to derive this one. This one we are deriving. Okay, W plus I am going to write VQ by T. From this we know Q by T. I is equal to Q by T. So power is equal to V into I. This is one of the important formula. This is first one. This is second. Third one is the third one. Power is equal to I square R. How to we can derive this one? I square R. For that we can see now derive P is equal to I square R. Power is equal to we know V into I. From Ohm's law, V is equal to IR. So in the place of V, we can write IR. Power is equal to IR into I. You understand? Here V is equal to IR. In this place we are writing IR. Then I into I square into R. This is the derivation of third one. Next, one more important formula is there. Power is equal to V square by R. Power is equal to V square by R. How to we can derive this one? Again we are taking power is equal to VI. We know from the Ohm's law V is equal to IR. Then I is equal to V by R. P is equal to V by R. Now take what is P is equal to VI. In the place of I, we are writing V by R. Then power P is equal to V into I by R. We can see power P is equal V into V square by R. This is the fourth equation, fourth formula. See, my dear students, here mainly what I am saying about electric power, we have four main formulas. First one is electric power P is equal work by time. Sometimes we can write power is equal energy by time also. Second one is there power is equal to VI, potential difference into current. Third one is there power is equal to I square R. Fourth one is there power is equal to V square by R. These four formulas we should remember whenever we study about electric power. One more important point here we should remember, 1 kilowatt hour, how many joules? This question so many times asking, 1 kilowatt hour is how many joules, means remember 3.6 into 10 to the power of 6 joules. Very simple. We see 1 kilowatt is 1000 watts. 1 hour is how many seconds, means 3600 seconds. Just we should multiply this to 1 kilowatt hour. 1 kilowatt hour means 1000 into 3600. Here see 36 into how many zeros? 1, 2, 3, 4, 5. 10 power 5 we can write joules. This is also correct only, but one decimal we can change. We can write 3.6 into 10 to the power of 6 joules. This is remembering is easy. This is the main things about electric power. Next very important thing is the last one, heating effect. Heating effect of electric current. Heating effect of electric current. Here H is equal to H is directly proportional to I square. H is directly proportional to R. H is directly proportional to T. Main thing, this is also very important. Then H is directly proportional to, from these three equations we can write I square RT. To remove this we can write I square RT. This is very important relation. H is equal to I square RT. Now we can see some more detail. Power is equal to work by time we know. This work we can write as a energy time. This energy we can write as a heat by time. So power is equal to H by time also we can write. It means H is equal to power into time. Power into time. Now see the first formula, H is equal to power place we can write VI. Then we will get VI into T. One. Second, in the power place, if we will write I square R, we will get I square R into T. Next, if power place, we can write V square by R, we will get V square by R into T. This is the main formulas about electricity. But here remember, this heat is directly proportional to I square. It means current is increasing, heat also will increase. This is only heating effect of electric current. If resistance also will increase, heat is increasing. If time is also increased, heat is increasing. From these three formulas, we can write H is equal to I square RT. H is equal to I square RT. Okay. And also these three formulas we should remember. H is equal to VIT. H is equal to I square RT. H is equal to V square by R. In this, they will give numericals. We can do any numerical from this formula. Those who are preparing for 10 board, this what I said now, this formulas are one time we can see any numerical we can do in the physics. Okay. Here mainly focus this also, 1 kilowatt hour, how many joules. If they will ask, for example, 3 kilowatt hours, how many joules? Then you just remember 1 kilowatt, how many? 1 kilowatt is 3.6 into 10 power 6 joules. So we can write 3 kilowatt hour is 3 into 3.6 into 10 to the power of 6. Then we will get multiply just 10.8 10.8 into 10 to the power of 6 joules. Like that, how many kilowatt hour they will use, we can do it. Thank you.